Hello, welcome. In this short video, let us look at an example where we verify whether a given system is linear or not. So we are going to look at an example where we verify the linearity of a system. In this video, we are going to look at this differential equation, that is a system characterized by the following differential equation: d by dt of y of t plus 3 times t y of t is equal to t square x of t. So that is the differential equation characterizing a system. Now we want to verify whether this system is linear or not. So for this purpose, consider two inputs, x1 of t and x2 of t, that have corresponding outputs y1 of t and y2 of t. So that means when we have dy1 of t dt, that is derivative of y1 of t plus 3 times t times y1 of t, should be equal to t square x1 of t. So that is equation number 2. So this is equation 1. So this is equation number 2. And then based off for the input x2 of t, the corresponding output is y2 of t. That means dy2 of t by dt plus 3t y2 of t is t squared x2 of t. So this is equation number 3. Now define another input y, define another set of inputs and outputs, that is x3 of t is basically a linear combination of x1 of t and x2 of t, that is b times x2 of t, and y3 of t is a linear combination of y1 of t and y2 of t. So a and b are basically constants. Now if we substitute x3 of t and y of t in the definition, that is in the equation 1, we get d by dt y3 of t, that is if x3 is the input and then y3 is the output, then we have derivative of y3 of t plus t times 3t times y3 of t should be equal to t square times x3 of t. Now we can replace y3 with the expansion, that is derivative of a times y1 of t plus b times y2 of t plus 3t times a y1 of t plus b y2 of t is equal to t square a times x1 of t plus b times x2 of t. Now basically gathering all the terms that have a as a common term, we get a times d by dt of y1 of t plus 3t times y1 of t minus t square times x1 of t, and then plus b times d by dt of y2 of t plus 3t times y2 of t minus t square times x2 of t is equal to 0. So since from equations 2 and 3 we can clearly see that if x1 of t is the input, then y1 of t is the output. So that means and similarly for from equation 3 we see that if x2 of t is the input, y2 of t is the output, then the linear combination y3 of t and x3 of t, that is x3 of t is a x1 of t plus b x2 of t, and y3 of t is a y1 of t plus b y2 of t. These two new inputs that are linear combinations of the previous inputs also satisfy the given differential equation based on equations 2 and 3. Therefore the system 1 is. So to summarize, we have looked at a differential equation that characterizes a system and verified that it is indeed a linear system. That is, given the equation dy by dt dy of t by dt plus 3t y of t is equal to t square x of t. We want to verify whether this differential equation is a linear system or is representing a linear system. So we first define two inputs, x1 of t and x2 of t, which have corresponding outputs y1 of t and y2 of t. So they both satisfy the equation 1. So we have equation 2 and 3. We define a new input x3 of t, which is a combination of the previous inputs, and we also define an output y3 of t, which is a combination of previous outputs. So now if we substitute these new input and output in the differential equation, and then we should get a linear combination of the previous equations. So, or that means we have, when we substitute them in the equation, we have d by dt of y3 of t plus 3t y3 of t plus t square x3 of t. And now we use the definitions of y3 of t and x3 of t, and we can see that the resulting equation is basically a times the first equation, that is equation number 2, and then b times an expression that comes from equation number 3. Therefore, indeed the new y3 of t and x3 of t satisfy the differential equation. Therefore, the system 1 is linear. Thanks for watching.